This is in-class exercise 3.7. Now we're going to put what we've learned about swells and drainage to practice on a actual building pad where we need to provide drainage around the building or around the pad. How we do that is we create what's called a horseshoe swell. The slope is going downhill this way. There's a pad here with an elevation of 29.05. That means every corner, it's just a flat pad. It's a pad that you would put a building on. That means each corner of this pad is 29.05. That's the elevation. This is on the side of a slope going from 32 down to 26, 1 foot contour intervals. What you're going to do is provide a 5-foot buffer around the pad with a 2% slope. That's what this dashed line indicates. They've already drawn the buffer, so you just need to figure out what those elevations are at the corners of that. And those elevations are all going to be the same, just like this building pad. All the corners are the same. And then the parameters down here, minimum slope 2%, so that's this 5-foot buffer. We're going to slope away from the pad at 2%, because even on this uphill where the water's coming down this way, the pad, you want to flow away from the pad on all sides, and they're saying do that at a 2% slope. Longitudinal slope is going to be 4%. That's what's going to be the center line of your swell. Remember the center line as the water flows through that swell, the long distance that it goes down that swell, that's the longitudinal slope. And then the cross slope are how far apart these contours will need to remain from each other on the sides going into that swell. And that's 4 to 1. This drawing here is at 1 inch equals 20. Up here they say to provide a high point of the swell, HPS stands for high point of swell, at 10 feet from the edge of buffer at a 4% slope. So let's get started. First thing we know, all these corners, finished floor, FFE stands for finished floor elevation. The finished floor of this pad is 29.05. So if we're going to go away for 5 feet at a 2% slope, what do we know? We don't know what the elevation is, so we don't know what the vertical distance is, right? And vertical equals horizontal times slope. The vertical, unknown. The horizontal, 5 feet, which they said provide a 5-foot buffer. So from there to there, if you scale that off at 20 scale, it's 5 feet. So our little math problem is 5 feet times our slope, which they said up here is 0.02, and that equals 5 times 0.02, 0.1, 0.1. So from this corner to this corner, it drops 0.1 feet vertically, and that's the same for all the corners. So 29.05 minus 0.1 equals 29.05 minus 0.1 equals 28.95. All right, so this elevation here is 28.95. So we'll write this here. 28.95. This one here is 28.95. This corner here is 28.95. And this corner here is 28.95. It's the same all the way around. This pad is flat, and then we just slope down equally at 2% on all the sides. Okay? So we've got the buffer around the building. Now we've got to locate a high point for a swell. And they say locate that high point for the swell 10 feet from the edge of the buffer. Now where that high point of the swell, it's going to be obviously on the uphill side of your building, which is this side up here. if these contours, because they happen to go basically perpendicular to your, or parallel with your building pad, that high point for that swell could be somewhere in the middle, because what we're going to want to do is take the water as it comes down and take some of it this way and some of it this way. So it makes sense to put it in the middle. If these contours were at an angle, like in our, let's see, the assignment we're going to do, let me show you. If they were at an angle, I can't find it, but if the contours, if instead of going this way, they were going this way, it might make more sense to put the top of the swell on a corner, going this way and splitting it this way. But because the water is just coming straight down this hill, it makes sense to just take it kind of in the middle and split it around the sides. And that's a horseshoe swell. So how we do that, we got to locate a 10 feet. So 1 inch equals 20. Let's go about the middle. So this is about the middle, 10 feet away. So right there. So let's call that, let's call that the high point. Let's call that the high point of our swell. And we're going away. We went 2% away here. Right? 5 foot buffer, 2% slope. So we went from 5% or 2% from here to here. To go from this buffer to the high point of the swell, you could go 2%, you could go 4%. You just want to continue. As the water comes down the hill, you want to make sure it goes this, comes down and goes this direction, not kind of keeps going, so up onto your pad. So this comes down at 2%, so we're going to come down and let's do this at 4%. We'll just come down because the longitudinal slope for your swell is going to be 4%, so let's use 4%. All right, so if we do that, we know, what do we know now? We don't know what the vertical is. We know that it's 28.95 here, but we're going 10 feet at 4%. It could be 2%, it could be 4%. Wouldn't go any less than 2% because 2% is the minimum, but let's use 4%. So it's 10 feet, because vertical, we don't know. We're going 10 feet times 0.04%. That equals 10 times 0.04 equals 0.4. 0.4 feet. So it drops from here to here, 0.4 feet. So we just go 28.95, which is this elevation, right, of this line. And we're going to subtract 0.4 feet, and that gives us 28.95 minus 0.4 equals 28.55. 28.55. So this elevation right here is 28.55 feet. That's our elevation, vertical elevation, 28.55. So now we've got water going away from the building, right? From the pad here, water going this way. We've got water coming down the hill to this point here, and then it's got to go this way and this way. For your swell is kind of a guess at this point, because you've got to maintain this 4-to-1 cross slope. So for your swells, just draw a light line that comes down kind of around your building like this. See, and you can draw one over here that kind of comes around your building like this. And I drew those softly because those are guidelines, because as I draw these contours on here, I have to maintain that 4-to-1 separation for the cross slope, right? So it may be that I can move this swell a little closer and save on grading, or it may, to keep that 4-to-1, I may have to push it out just a little. Excuse me. I don't know for sure, but this is pretty close. So you just eyeball in an approximate swell line, so to give just to guide you. So this is 28.55. What's the next contour we've got to get to? If this is 28.55, we've got to get to the next whole contour going downhill. So that's contour 28, right? Because 28 is the next contour below 28.55, and we're going at a longitudinal slope of 4%. This line right here, that's the longitudinal slope of this swell, and they're telling you it has to be maintained at 4%. So we know our vertical drop, we're going to drop 0.55 feet. 0.55 is our vertical. We don't know what our horizontal is, but we know that horizontal equals vertical divided by slope. So we have to go 0.55 divided by the slope, which is 4%, 0.04. So 0.55 divided by 0.04 equals 13.75. Let me write this, 13.75. It's going off the page there. So what that means is from here, horizontally, we've got to measure 13.75 feet for contour 28. So at 20 scale, right, it's 20 scale, that's about 13.75. So it's right here. So that would be contour 28. Okay? Now, what do we got to do? Now we've got to go from 28, we got to go to 27, 26. So now it's a 1 foot drop, right? So instead of this 0.55 divided by 0.04, we got to go, the vertical is 1 foot divided by 0.04, that slope. So let's see here. 1 divided by 0.04 equals 1 divided by 0.04, 25 feet. So now we know that each contour at 4%, each contour is going to be 25 feet away from the other one. And the way you do that is you just kind of see here, this is how I do it. I'll go, I'm showing this just so I can turn it, but this is about 10 feet right there, right? From there to there. And then I turn my scale. I go another roughly 10 feet. And then I got to go another 5 feet, roughly right there. So I just measured with my scale. I just kind of had to roll my scale to get 25 feet. So this is 28, 27. And then I got to go another 25 feet. So there's, can you see that? 10, 20, 25, kind of roll it, 25 right in here. So that's about 25 feet. See that? 25 feet. That's contour 26. Okay. Then we got to do the same thing over here. We said that this is going to be the same going the other direction. So from 28.55, we got to drop this 0.55 feet divided by the 4% slope equals 13.75. So if we just measure 10, 11, 12, 13.75, puts us right about here. So that's 28. Okay. And then we said it's 25 feet. So now we've got to measure. There's 10 to there. Then I roll my ruler. There's another 5. 15, so there's another 20 right there, 20, and then another 5 puts me at 25. So that right there is about 25 feet from there on that curve. So this is 27, and then I got to go another 25 feet to here, and that's 26, right? So now we have our swell. This 28 has to be, this is where we start, 28. Now we've got this corner here is 28.95. So how far does contour 28 have to be from this corner? Well, we have a cross slope of 4 to 1. That's almost a foot, right? From 28.95 to 28 is almost a foot. It's 0.95. So instead, if you want to get exact, you just go 0.95 times 4 equals 3.8. I went 0.95, because that's how far away we are, right? 0.95 feet. We aren't a whole foot, so if you just do that and you multiply that by 4, it tells you that it's 3.8 feet. 0.95 times 4 equals 3.8. Another way you could do it is, we know that it's 0.95, right? Horizontal, where is it? Horizontal equals vertical divided by slope. Well, the vertical is 0.95. Oops, off the page. 0.95, and you divide that by the slope, which the slope is 4 to 1, right? The cross slope is 4 to 1. That's a 25% slope, right? Divide 1 into 4, 25%. So 0.25 equals 0.95 divided by 0.25 equals 3.8. So either way, it's 3.8. So 38, contour 38 has to be at least 3.8 feet away from this contour of, or from this spot elevation of 28.95 to maintain that 4 to 1. Let's just call it 4 feet. So if you go 4 feet away, that's where I just measured over 4 feet, 3.8, and then you draw like that. That's going to be that contour. The other thing we need to do is we've got to draw contour 20. This is 28.95, 28.95, 29. Contour 29. See, contour 29 falls in between here on this pad, right? Because 29.05 is 0.05 higher than elevation contour 29. So where is contour 29 going to be? Let's do this one horizontally. Vertical divided by slope. This is 29.05, so we know that vertical is 0.5 feet. So we go 0.5 right away, and we divide that by the slope. And what's the slope of this area right here? We said that that was 2%, right? We said 5-foot buffer with pad, the pad with a 2% slope. So we got to divide it by 0.02. That's the slope. So let's do that. 0.5 divided by 0.02. Oops, that's not 0.5, that's 0.05. 0.05, right? Because it's 0.5. I had that wrong. So 0.05 divided by 0.02 equals 2.5. 2.5 feet. So it's horizontally, it's 2.5 feet away from this line here, because this line here is 29.05 all the way around. If you measure 2.5 feet, that's it. So that contour goes all the way around, and it's 2.5 feet, which is right in the middle, right? So it goes around like this. This is contour 29. That's contour 29 goes all the way around the pad. It's like an island. So now, if this is 29, from this corner here, we figured out, right? This is 29.95. So this has to be basically that. Remember that 3.8 feet away or 4 feet away to maintain that 4 to 1 requirement. So your contour, if we measure let's just do 4 feet, makes it easy. 4 feet, we come down. All right, so here now we're maintaining that 4 to 1. This is contour 28. So where's contour 28? It's right here. This is 29. So we have to maintain that same, that 3.8 feet all the way around. Right? So same thing for, and then you got to come around here, that. Okay? So now contour 27. See how far out our swell is? It only needs to be 4 feet apart. So there's 4 feet because of the 4 to 1. 4 to 1 right there. So contour 27 only has to be 4 feet away. So if we did that here, 27 has to be 4 feet away all the way around. We're just doing one side, so it comes around here, up, and then this could actually be, right, it could be closer. Let's just end that right now. 26 has to be 4 feet away. So we've got this right here, right? So 26 has to stay 4 feet away. So that's why I'm saying this contour, you know, this swell, I mean, could be brought in a little closer because we have it clear out here, but see, it doesn't need to be that far. It could be something like this. And this is 26. We're tying back into 26. So same thing over here. This is 27. We just got to go in and we can tie back into 27 here. See, that's way more than 4 feet. So we could actually pull this contour in if we wanted to a little bit, right? Because it only has to stay 4 feet away. So we could actually pull it in closer. Like this. And that ties back into there. Yeah. Pen keeps breaking. Pencil. So, you know, we're at least, that's further than 4 feet, the 4 to 1, so it's actually 6 feet. So then 28 has to tie back in. This is contour 28, so 28 has to cut, and it just has to stay 4 feet away, right? It's 4 feet. So it comes down. So this just has to come there, like that. So your swell is going, remember we do the lines like this, right down the contour. There's your swell. Can you see that? So it's going like that, and it's going at 4% because we did these 4. So we write 4%. And you've got that swell. So see, the water is going off the building into the swell. It's coming down this way, you know, perpendicular to the contours into the swell, and then around the building. Now we've got to do the same thing over here. Same thing, this is 28.95. So the contour has to be, from here, we have to be 3.8 at least. Like I said, it could be 4. As long as it's more than 3.8, which is this number right here, 0.95, right? 28.95, we got to get 0.95 away. But since we're off of this, it has to have that 4 to 1 cross slope. So this just goes down. And then this has to go all the way around, right? And tie in here. And then this is 28. We had that same separation, the 3.8 from here to here. That. And then let's do, so that's 28, 27. So right here we have to be 4 feet. We have to maintain 4 foot away. Right, that's that. So as long as we go like this, we've got that. Come around. And then this one ties in there. And actually, it doesn't tie in there because we've got to keep 4 feet. See this contour? We need to be 4 feet away for 26. So it actually has to go something like that. And then come across here. And go up. Whoops. Keep that again, that 4 feet away. So this is 4 feet distance. Right? So this is, each one of these are 4 feet away. 4 feet away, 4 feet from there to there, 4 feet from there to there. That's that 4 to 1 cross slope, 4 to 1. So now we can come tie back in to 26. 27, we just come back down, tie into 27. 28, as long as we stay 4 feet away, right? 4 feet. 28 is fine just like that. There we go. So here's this swell. Comes down, arrows for your swell line. Look at that, we're taking the water around the building, 4%. That's our 4% longitudinal slope, 4% longitudinal slope, catching that water at this high point. Comes down the hill, goes into those swells and around your building. Our pad's perfectly flat. We're coming down at a 4 to 1 slope on all the sides. That's it. You've got a little, first little drainage problem solved with a horseshoe swell around your building pad. So that's what it, hopefully with this video and going over it in class, it'll start to make sense.